Alright, so for my CS 2400 or CS 4900 final project, I did particle interaction optimization, which ended up being a bit of a galaxy simulation sort of thing, which I think works pretty well and it looks good. Um, Tried to pick a background with good contrast so you could see it. I don't know how that's going to come out in the compression, but yeah. So, okay, let me run through. I'm going to let this run, see how it develops. I'll just put it in the background. Okay, so the main parts of the project were the nebula points class, which it does all the physics, and all of the rendering. It inherits from a MGL point set shader accelerated, and it takes a bunch of vertexes and initial velocities and turns them into points. Yep, and it has a physics step here, which it originally didn't take from the Octree, but now it uses information from the Octree to determine the forces acting on a point, and then it exerts those forces, and then it updates the visual representation. Some cool stuff I did with this is I have it set to as soon as the position updates, we use that to update the bounding box for the Octree. That way, the Octree is only ever as big as it needs to be. The only caveat to that is the initial Octree needs to be bigger than all of, it needs to be guaranteed to encompass all the points. That way, they can all get added the first time, so that they can physics tick once, and then it optimizes it. And I have it set to be twice as big as the maximum point, just in case. If it's 100, but a point is moving at 200 velocity, it'll step out of the Octree before it updates to the bigger size. Okay, and then here, the Octree itself is pretty straightforward. Every leaf has one node, or every node that is a leaf has one point in it, and then each branch node along the way has the average of center of mass of all of its child nodes. So you can approximate far away interactions with the by using a branch node and ignoring all of the child nodes, which actually means as the simulation goes on and the points get further apart, it actually speeds up because it's sparser. And then you just calculate the center of mass, and all of this is recursive, basically. This does recursively, and then destroying everything is done recursively. Subdividing, this was kind of a challenge because we have to shift the point that's in a subdividing node down before we can add the other one. So sometimes you end up with a couple steps in there, a couple additional additions in there to shift the node or the point that's already there down. Okay, and then I have just structs, and that way I can, this is for a node, just has everything in here as pointers, basically, for pointing to other nodes. And actually, I don't even use the parent pointer, so I could get rid of that and save a little bit on the memory. Now I need to open something that I don't have. the point has the velocity, position, and acceleration, and then I'm not using the ID either, but I figured it could be useful if I needed it, and it's not that big. So, and then the mass, and the mass is different than can be different for each point, but right now all I have it is the black hole, quote unquote, in the center is the biggest one, and I sort of want if I was to do this a little longer, I would make a configuration file or maybe a configuration menu where I could tweak all of the masses and accelerations and weights for everything, and the theta, which is that determines how far away um, a node needs to be before it is considered like a faraway node, and the children can be ignored. And let's see here. And then I did a galaxy generator, which is not super complicated. It was really the placing of everything was pretty easy. It was tweaking the initial velocities and the making sure that there wasn't like too much above, because like it needed to be in the ecliptic essentially. I needed to make sure that it was mostly in the ecliptic, because if it was too much out of the ecliptic, it would basically spin off into multiple sub galaxies, which was kind of cool. But I don't have enough points to really accurately make those look good, because I pretty much ran into a barrier of I can have about 1,200 points, which is about 10 times. Well, I think it's about 6 times more than the amount I was able to do without the Octree. I think I was only able to get about 300 working at like an acceptable like 15 or 20 frames per second without the Octree. So adding the Octree got me like 6 times speed up, which is pretty good. And the benefit of that is the Octree is still pretty accurate. Like the far away points, the points that are way out on the edge, they're still being able to interact with this center of mass, so they're still accurately or somewhat accurately rotating around the gravitational center, which is what I was running into when I was trying to do my previous method. So I haven't. It's hard to get. I was hoping I could get gravitational spiral like spiral arms to form, but I don't think I have the right balance of masses and count of points, because I feel like I need more points to make that work, so that you can actually have like a genuine tendril coming out. So I've only been able to do a decent job of globular galaxies, but if you zoom out far enough, excuse me, if you zoom out far enough and you come down and you look at it, it looks very galactic, and then you can like cruise through it it's probably terrible for the compression, but yep. I think this is something I want to work on a little more in my personal time. Maybe getting like maybe threading like on the CPU side the motion of it. That way I can at least speed that aspect up, because I think that might be what I'm running up against. Is the actual physics step, because that is done sequentially, completely. Well, everything's done completely sequentially, but I think that's what's pulling us back, because the actual number of forced calculations isn't too many, because as they get closer, it has to do with how big the cells are. So even though they're really close, the fact that they are smaller cells makes them still do a lot of approximation. So even though they're all right up next to each other, if there's a ton in one spot, they're still doing a lot of approximation for all the other ones, because it's done on a point by point basis. So um, yeah. And I think that is the majority of the really interesting stuff. I have a ton of parameters I can tweak to make different outcomes. A lot of them are really ugly, though, so it's or just like spin out into like a ring, which is not super exciting to look at. And I can tweak all the weights and stuff. It, yeah, there's a lot of tweakability here that is just produces ugly, ugly galaxies. But I think that's all I have.